Welcome fellow learners. In this video, we will learn how to cache LLM responses using Langchain framework and how it can be beneficial in building generative AI based applications. Caching LLM response could be a simple topic, but it can be a really good tool to have it in your armor. So let's first see what are the benefits of caching LLM response. So the first one is it can be really cost effective, and how it does is it reduces the number of API calls that you make to your LLM providers like OpenAI, Gemini or Claude. The second one is it also speeds up your application by reducing the number of API calls. So in this video, we are going to cover two types of caching. The first one is in-memory caching, where we save these LLM response in the RAM. The second one is persistent caching, where we save these LLM response in the database like SQL database. So let's see what are the different steps that we are going to follow in this notebook. So the first one is we will see how we can implement in-memory caching using this Langchain framework. In the second step, we are going to import the LLM. We are going to use OpenAI LLM. In the third step, we are going to see how we can use this in-memory caching and save these LLM responses. In the fourth step, we will see how we can do this caching LLM response in SQL chain. Then we will also see how we can do this caching LLM response in Langchain agents. And finally, we will see how we can use persistent caching and improve the speed and reduce the cost of your application. So let's get started. Let's first see how we can utilize this Langchain to implement this in-memory caching. We first need to import two modules, in-memory cache and setLLM cache. We can utilize this Langchain core to import these two modules. The first module, in-memory cache, will make sure that whatever LLM response that we want to be saved will be cached in RAM only. And this setLLM cache module will make sure that this in-memory cache technique will be set globally for this notebook. So let's run this cell. Then we can create an object of this in-memory cache and then pass that object into this setLLM cache, and this in-memory cache will be set up in this particular notebook. Now at the start, this cache will be empty, and we can call this particular argument from this cache, and we can see at the start there will be an empty dictionary. Now we have initialized this in-memory caching. So in the next step, we are going to import the LLM. For the LLM part, we are going to utilize the OpenAI LLM, and we are going to use GPT-4o mini model. So we first need to import this chat OpenAI module from Langchain OpenAI. So let's run this cell. Then we can pass these parameters to this particular chat OpenAI module to initialize this LLM. You can see that I have passed this OpenAI API key, which is already stored in my system variables. And another argument that I have passed is temperature equals to 0, which will make sure that outputs are consistent. One more different argument that you might be seeing over here is cache. So I have commented this particular argument. The reason is because we are already using set LLM cache, which already has made sure that this particular in-memory caching technique is set globally for this particular notebook. So let's run this cell, and this particular LLM will be initialized in this notebook. So let's pass a simple query to this particular LLM, and let's see if it is working correctly or not. So I will just invoke this particular LLM. So let's just pass a simple query like hi and see what does it respond back. So we can see it has responded like hello, how can I assist you today? So we can see that this LLM has been initialized correctly. So now we have set up the LLM. We have also initialized the in-memory cache. So let's see how does this caching technique helps us in simply querying an LLM. So let's first run a simple query and pass a simple query to this particular LLM. So you can see over here, like I have passed a simple query like who is the president of India. So let's run this cell, and we can see that it took around 1.2 seconds to run this particular query, and it has given a response like as of my last knowledge updated in October 2023, the president of India is Draupadi Murmu. So now what we can see if that particular cache, that in-memory cache has been updated, like has it saved anything or not. So first we can print the length of that cache. What we can do, cache dot underscore cache, and it will show us if there is anything has been saved in this particular cache or not. And you can see there are two responses has been saved in this particular cache. So the first response that should be saved is this particular query that we have made to this particular LM, that this hi, and second query and their response, this who is the president of India, has been saved to this particular cache. So what we can do, we can simply print what has been saved to this particular cache also. So like we can run this cache dot underscore cache,
and over here you can see the response and that LLM string also saved over here. So like the input was high and the response was written over here. So you can see the response like how can I assist you today is written over here. Similarly for the second query, who is the president of India is the query that we have asked, and corresponding response is written over here like as of my last knowledge the president of India is Draupadi Murmu. So great, we can see that uh, this in-memory cache has worked and it has saved this particular LLM response and the corresponding query uh, to this particular cache. Now, how does it work? Like if we ask the same question to this particular LLM, it will first see in the cache, this in-memory cache, that is there any particular cell or row has already been there, which is having the same query already stored there. So if we ask the same question like who is the president of India, so let's see what does it do. So you can see it didn't took any time. It ran very quickly and it has provided the exact result that it has provided earlier. So like as of my last knowledge, the president of India is Draupadi Murmu. So we can clearly see that this caching works with simply querying to the LLM. Next, we will see does this caching also works with SQL chains and agents or not. So like we will first create a simple SQL chain. So here you can see I have imported a particular database which is Chinook database. So let's run this cell and we can also print what does this data contains. So we can do db.table info and it will showcase all the tables and their schema that are written in this particular database. So we can print this. You can see these are the tables, track, playlist track, and all others playlist and all other tables over here. So this is a database that I have imported. Now I will create a simple chain, which is a SQL chain. I will utilize this create SQL query chain from Langchain to basically create this chain. So let's run this cell. Now we can utilize this create SQL query chain module and pass this LLM and database to it, and it will create this chain for us. And then we can invoke this particular chain. So you can see over here, I have asked a simple question like how many employees are there. So let's run this cell and let's see what does it respond back. So you can see it has created a SQL query for us. So like select count employee ID as employee count from employee, which will gives us like how many employees are in that particular employee table. So now let's see does it also being saved in that in-memory cache or not. So what we can do same like cache dot underscore cache and we will see does it updated that particular in-memory cache. So you can see there is third row updated in that particular cache. So over here you can see this was the prompt that was passed to the LLM and you can see over here this was the response from the LLM. So great. This has also been saved to that particular cache. Now if we run the same query again, let's see does this caching works or not. So we can clearly see that it took a really less time and it basically given us the same response as earlier like select count employee ID as employee count. So in this way, you can utilize this in-memory caching with your chains also to make your system faster and also reduce the number of API calls, which will saves your cost. So next we will see does this caching technique also works with agents or not. So like as you know, chains are basically sequence of action. So as in our case, in this particular SQL chain, we pass this particular query, how many employees are there, and it will be passed to a prompt. That prompt will be created, and then that prompt will be passed to an LLM, which will generate an SQL query. So this is a simply a sequence of actions. While an agent is basically runs loop of sequence of actions. So like as per the requirement, if it requires to run that particular sequence again, it will run and then think about it. That particular LLM will think about it. Does it have reached the stop condition or not? And as per that condition, it will revert back the answer. Or if it hasn't, it will again run that particular sequence. So we need to see will this particular caching technique also works with agent. So over here I will be going to use SQL agent. So like this agent I will be using this create SQL agent from Langchain community. So over here you can see I have created a simple prompt. You are an agent designed to interact with an SQLite database and uh, you need to basically given an input question, create a syntactically correct query, then look at the result and create a query and return the answer. So this particular agent is being created over here. So I have passed the LLM, that OpenAI GPT-4o mini model. I have passed the database, that Chinook database. I have passed this prefix, this particular prompt, and then I passed this agent type. The agent type that I have passed over here is React agent, which will make sure that it first reason out like which particular step or tool it needs to basically perform, and then as per that particular reasoning, it will take action. Now an important argument that you need to remember is string runnable equals to false. You need to pass this particular argument always whenever you want any agent to cache the LLM response. So like these create SQL agent or any agent in Langchain are utilizing runnables. So in case of runnables, if you are streaming or this particular string runnable is passed as true, it will not cache any LLM response. But if you pass this stream runnable equals to false, it will make sure to cache your LLM response. And as we have already set up that set LLM cache, and that has made sure that that in-memory cache technique is being set globally. So it will run for all the invocation of the LLM that we are doing in this particular notebook. So this will create our agent. And finally over here, you can see I have passed a simple query like how many total artists are there. So I have passed a little different query such that it will not take the response from the earlier query. So let's run this cell and let's see how much time it takes and what is the response does it gives back. Now you can see it has given us the response like there are total of 275 artists, and let's see how many entries are being added to that particular cache. So as you know, this particular agent takes a lot of step to provide us the final result. So over here you can see now there are total number of 9 entries in this particular cache. Earlier we have seen that there are total only 3 entries. So it has added there 6 responses from LLM to this particular cache. So now let's run the same query again to this particular agent and let's see does it respond back instantly or not. So you can see that it has responded back instantly and it has provided the same correct result like there are total of 275 artists. So great. We can see that this caching technique also works with agent. We always need to make sure that we are passing this stream runnable equals to false argument to this particular agent in whenever you are using any LangChain agents. So now there is one more method that I want you to know that you can use this clear method to clear all the input to the cache. So let's run this cell. Now when you print that cache, you will not see any cache in that particular in-memory cache. So over here you can see it is now having empty dictionary. Now we have seen that how we can utilize the in-memory cache uh, by using agent, by using chains, and also simply passing simple query to the LLMs. In the next step, and which is the final step, we will be seeing how we can use persistent caching technique with these LLMs. So what is difference here? Like in-memory cache will save your LLM response in the RAM. So like it will only work in that particular session and it will not work whenever you want to cache anything after that session. But in the case of persistent caching, it saves the response in a database such that if you want to basically get back that particular cache or LLM response at later time, you can do that. So let's see how we can implement this persistent caching with the LangChain. So over here you can see I have written two commands. One is using Python and second is simple command that you can run. So these two commands meant for the same thing. Like if there is already created database which is named as langchain underscore db, it can be removed. So let's run this cell and you can see as there are no particular langchain underscore cache database are there. That's why it has given us this particular error. Similarly, you can run this particular command and as there are no langchain underscore database, it will also say that it couldn't find that particular file under this particular path. So now we know that there is no database already there. So what we can do, we can create a database using SQLite cache. We can import this particular module from Langchain community. So let's run this cell and you can see I have passed this langchain underscore cache dot db argument to this particular database path. Now this particular cache has been created. So this is basically a persistent cache that has been created. And you can see what I have done different this time is, instead of creating that in memory cache, I have passed that cache, this SQLite cache, over here. Now you can also do the same thing, like instead of passing this cache to this particular LLM, what you can do, you can use that set LLM cache uh, and then pass this particular SQLite cache object to that particular set LLM cache such that it can be set globally for this particular notebook. But to give you an example of this type of passing argument to LLM also, I have created this type of LLM in this time. So let's run this cell. Now this LLM has been created. So let's run a simple query to this particular LLM, LLM dot invoke, and let's say we passed hi, and we can see that it has given us this response, hello, how can I assist you? And you can see it ran for around zero point 0.8 second. Now I have created a simple function which will gives us the response whatever the data that is being stored in this particular Langchain underscore cache. So as we have run this particular query to this LLM.invoke, there should be one row which should be already stored in this particular persistent cache database. So in this particular cache, Langchain underscore cache, this data should already be stored. So let's run this cell, and you can see that I have printed this number of entries to this particular cache, this database, and you can see there is only one entry to this. You can see a lot of data in this particular entry, which basically comprises of that LLM string, that OpenAI string, like its argument, what are the different arguments that we have passed to it, and also the input and output that we have passed to it. So like input query and the output that we get from the LLM. So this is the output that we get from the LLM, and over here you can see this is the input that we have passed to the LLM. So great, we can see that this way also we can store the output from the LLM response in a persistent database. Now let's ask a simple query to it. So let's ask who won the 2007 T20 World Cup, and let's see how much time does it take. So you can see it took around 1.1 second, and it has provided us the response like India won the inaugural ICC T20 World Cup. Now let's ask the same question, exactly same question to this particular LLM, and you can see it didn't took any time and it has provided us the same response. So we can see here that this persistent caching also works, and you can utilize this as per your requirement. So if you want to use caching in that particular RAM only, you can utilize that in memory caching, or if you want to save your LLM response in a database to use it later time, you can use persistent caching. So great, I hope you got the gist of how you can utilize this caching technique to store your LLM responses, and how it can speed up your application and also reduce the cost of the application. So thanks for making till the end of this video. Goodbye until the next time.